When the temperature starts falling, rain turns into snow and ice, so the traction requirements for tires start to change. Perhaps the biggest differences are longer braking distances and reduced lateral grip during turns in winter conditions. In order to offset the loss of traction, manufacturers have developed tires with special tread designs and compounds that perform better on road surfaces covered in water, ice, snow, and slush. While most consumers refer to these tires as snow tires, the proper term is winter tires, since they offer benefits in any road conditions below 40 degrees Fahrenheit or 4 degrees Celsius, not just snow. These tires are usually identified by the Severe Service emblem, which is a unique mountain and snowflake symbol molded on the sidewall. This symbol is not to be confused with the letters M and S, which are typically associated with all-season tires. Most people believe that the letters M and S mean mud and snow, but they actually designate a tire with a specific tread-to-void ratio. In other words, the M&S designation is based entirely on the tread design, so it is not an accurate reflection of how it will perform under winter conditions. A tire is not required to meet any specific performance criteria to be labeled M&S. On the other hand, the mountain and snowflake symbol used to identify winter tires is based on a specific test designed by the American Society of Testing Methodology, or ASTM. This means a winter tire must pass the ASTM test, so the designation is based solely on how it performs on snow and ice. As a result, drivers can expect winter tires with this symbol to perform better than all-season tires and significantly reduce the required stopping distance and improve turning abilities in winter conditions. Winter tires also help combat slush planing, a very hazardous winter driving condition. Another type of winter tire provides even more traction through the use of studs in the tread blocks. The addition of studs further decreases stopping distances in winter conditions and gives the driver increased handling, especially on ice. Studded winter tire technology has improved over the past few decades to minimize the amount of in-car noise and road damage. That being said, it is important to note that state and provincial governments often place restrictions on the use of studded tires and may not allow them at all. For a complete list of studded tire regulations, go to the following website. The first step when selecting a set of winter tires is to check the vehicle placard for the recommended size and load index. On this vehicle, the correct size is 205/55R16 and the load index is 91. The best practice is to always use the size and load index listed on the vehicle placard. If a different size is used, the outside diameter of the replacement tire must be within plus or minus 3% of the tire listed on the placard. And if a different load index is used, it must be equal to or greater than the original equipment tire. Another piece of information on the placard that must be considered when selecting winter tires is the speed rating. While the letter represents the maximum speed for the tire, it can also be explained as a performance rating, since it reflects how a tire will perform at highway speeds. When replacing all-season or summer tires, the best practice is to maintain the speed rating on the placard. For winter tire applications, it is still the best practice to use the speed rating listed on the placard. However, most winter tires have lower speed ratings than their all-season counterparts, so the rating on the placard may not be available for a particular size. When lowering the speed rating on winter tires, retailers should advise the consumer that the performance capabilities of the winter tires may not be the same as the all-season or summer tires that were previously installed on the vehicle. It's also important to make sure winter tires are installed on the proper wheel positions for the type of drivetrain on the vehicle. For example, on rear-wheel drive vehicles, it is acceptable to only install 2 winter tires on the rear drive axle. While it used to be common practice to install winter tires only on the drive wheels on rear-wheel drive vehicles, tests have shown this can be a dangerous practice, resulting in a front axle that has no traction, which can lead to a vehicle with an understeer condition and loss of control. On the other hand, when the difference in traction causes the rear axle to lose control, the vehicle develops an oversteer condition. This can occur when new all-season tires are installed on the front axle of a front-wheel drive vehicle and the worn tires are moved to the rear. As a result, when winter or studded tires are installed on front-wheel drive vehicles, they must be installed on both axles. In this test, the passenger car was able to safely navigate the turn on snow and ice when winter tires were installed on both axles. When winter or studded tires were installed on the front axle and all-season tires remained on the rear, the front-wheel drive Golf lost control in the turn. Therefore, whenever installing winter or studded tires on the front axle of a front-wheel drive vehicle, winter or studded tires must also be installed on the rear axle. The same principles also apply to four-wheel drive and all-wheel drive vehicles. When winter tires are installed on both axles of the SUV, it safely navigated the turn on snow and ice. However, when winter or studded tires were only installed on the front axle, the difference in traction led to the loss of control, even with all-wheel drive, anti-lock brakes, and electronic stability control. Finally, the National Highway Traffic Safety Administration, or NHTSA, recently ruled that when winter tires are installed on a vehicle with a functioning tire pressure monitoring system, or TPMS, the system must continue to function. Which means that consumers who want to install winter tires on a different set of rims must purchase new sensors or transfer the sensors from the summer assemblies to the winter tires and rims. Retailers who install winter tires without TPMS sensors are knowingly disabling the system and violating the Make Inoperative provision of the Motor Vehicle Safety Act 49 U.S.C. 30122B. Perhaps the most important advantages of winter tires are the reduced stopping distance and improved lateral grip on snow and ice. The tread pattern and rubber compound are specifically designed to prevent slippage in winter conditions, allowing the vehicle to stop more quickly. These advantages also translate into better lateral control when turning on snow and ice. As you can see, the tread design preserves lateral traction, so the vehicle can maintain a consistent radius on a curve. This is important because the loss of lateral grip can result in the loss of control or a rollover, so it is one of the leading causes of winter driving accidents. Another advantage of winter tires is the improved performance on hills and inclines. The tread blocks and special rubber compound combine to provide the vehicle with improved ability to climb an incline and descend on snow-covered road surfaces. In order to demonstrate the superior performance of winter tires in snow and ice conditions, a series of demonstrations were conducted at the Nokian Tires Proving Ground in Ivalo, Finland, about 175 miles north of the Arctic Circle. A 2013 front-wheel drive Volkswagen Golf with a 5-speed manual transmission was used to represent the passenger vehicle category. The identical vehicles were equipped with anti-locking brake systems and electronic stability control. In all of the tests, the red Golf was equipped with standard all-season tires, while the black Golf was equipped with either winter or studded tires. For the SUV category, a 2013 all-wheel drive Volkswagen Tiguan with an automatic transmission was used. The identical vehicles were also equipped with anti-lock braking systems and electronic stability control. In all of the tests, the darker Tiguan was equipped with standard all-season tires, while the light gray Tiguan was equipped with winter or studded tires. In the first demonstration, all-season tires were compared to winter tires in an acceleration test on ice. As you can see, the winter tires on the SUV to the right performed much better. When the studded tires were installed on the same vehicle and compared to all-season tires, the performance of the SUV on the right improved even more with the additional traction. Repeating the test with the passenger cars showed the same result when winter tires were compared to all seasons, and the same level of improvement when studded tires were compared to all-season tires on ice. A similar acceleration test on packed snow also shows the improved performance that winter and studded tires provide when compared to all-season tires on the SUVs and the passenger cars. Another advantage of winter tires is the ability to climb an incline. In this test, the SUVs were started from a dead stop at the base of the hill. As you can see, the winter tires on the left provided much better traction than the all-season tires on the right. And when the same test was conducted with the passenger cars, even the running start wasn't enough for the all-season tires to climb the hill, while the vehicle with the winter tires had no problem making it to the top. While acceleration is important, stopping distance is still the most important feature for most drivers, especially on snow and ice. In this test, the passenger cars were stopped on packed snow at identical speeds to measure the difference in stopping distances. In test after test, the car with the winter tires required less distance to stop when compared to the car equipped with standard all-season tires. Likewise, the studded tires also required less room to stop on packed snow when compared to all-season tires. The same can be said for the SUVs on packed snow, since the winter tires reduced the stopping distance, and the addition of studded tires showed the same level of improvement when tested against all-season tires. When the passenger cars were tested on ice, the differences between all-season and winter tires were even more dramatic. In test after test, the car with winter tires required less distance to come to a complete stop. And when studded tires were tested against all-season, the stopping distances for the passenger car with studded tires were even further reduced. Repeating the tests on the SUVs showed the same results with the winter tires outperforming the all-seasons when stopping on ice. And the studded tires showing even more improvement in stopping distances when compared to all seasons. When road surfaces are covered in snow or ice, the stopping and handling ability of the vehicle is going to change. The degree of change depends on the amount of traction between the tires and the road. In climes where sub-40-degree temperatures or snow and ice can be expected for months at a time, standard all-season tires cannot be expected to perform and deliver in terms of handling and stopping. On the other hand, when winter or studded tires are properly installed, drivers can expect improved performance when compared to all-season tires and significantly reduce the amount of space needed to stop a vehicle on snow or ice. And given the superior handling characteristics of vehicles with winter or studded tires during lane changes, turns, inclines, and declines, they are a natural solution for drivers who are concerned about safety when encountering winter road conditions.